Okay, I'm going to go ahead and record the last example in 2.6 now. This one was a little bit lengthy and the previous example was lengthy, so I was worried that something might happen and my data might not save if I didn't stop the last video. So this is the last example. It's pretty tricky, but it will give you a lot of I think needed tips and tricks and ideas that you'll need to solve these type of questions. Okay, so last example in the 2.6 notes. We want to calculate the limit as x goes to negative infinity of root 4x squared plus 3x plus 2x. So the first thing that you're probably seeing is, I don't have a fraction here, right? So we know if we run the limit through, we'd get, a negative infinity squared plus 3 times negative infinity plus 2 times negative infinity, which is just weird to think about because you can't even multiply things by infinity. So we know we need fractions in there. We discussed that that's helpful. So the first thing that we're going to have to do is get fractions in here. So we need fractions. These are helpful when taking limits as x goes to infinity or negative infinity. X goes to infinity and or negative, I'll say or, probably not and, or negative infinity. All right, so now we think, okay, well, how do we do that? Well, with this, we need to use a little trick that we learned, and I think a couple people in your class talked about on the discussion board in section 2.3. I know I talked about on the discussion board too. Okay, so what you should see here is, wait a second, I have a square root plus some other term. Recall from section 2.3 that when you have this, it's oftentimes helpful to multiply by the conjugate, and you have to multiply by the conjugate in fraction form because then it's really just equal to 1 and you don't change your expression at all. So your goal right now is to write this in such a way that you're not changing the expression, you're not changing what you're working with, but you're making it look easier for yourself to work with, or making it look in such a way that you can work with it. All right, so what I mean by that is, let's look at the limit as x goes to infinity, to negative infinity, that's another little thing we'll have to deal with soon, of root 4x squared plus 3x plus 2x. All right, as mentioned before, the two unhelpful things with this expression right now are that it has a square root in it and it has no fraction. We're going to take care of both of those problems with one step. So I'm going to use that trick from section 2.3 to help myself out. I'm going to multiply this by the conjugate. So that would be 4x squared plus 3x minus 2x. All right, I can't just leave this like this. In your head, you should think, oh, why? And hopefully you can answer this question. If I just leave it like this, I'm completely changing the expression that I'm working with. That's not mathematically valid. So what I do is divide this by, or turn it into a fraction, 4x squared plus 3x minus 2x. What this does is essentially lets me multiply my expression by 1, which I know is technically not changing it at all. All right, let's see how this helps us out. Okay, so this is equal to the limit as x goes to infinity of, I'm going to FOIL out the numerator. Okay, keep in mind this term is really over 1, technically is the same thing. So I'll FOIL out the numerator. That would give me 4x squared plus 3x. All right, the minus 2x times the radical and the plus 2x times the square root, radical, whatever you want to call it, would go out to 0. So I know those two terms zero out, and now I'll multiply my last terms. So 2x times negative 2x would be a minus 4x squared. I'm already pretty happy with how that works. All right, so in the denominator, I am left with 1 times 4x squared plus 3x minus 2x. All right, numerator looks awesome here, simplifies really nicely. So we have the limit as x goes to infinity of 4x squared minus 4x squared is just 3x. And this is a negative infinity. I keep forgetting to write that, sorry. Okay, in the denominator we have root 4x squared plus 3x minus 2x. All right, so looking at this, now I should be thinking, okay, that looks a little bit nicer. I at least have a fraction to work with. However, if I run my limit through right now, I can still see that this is going to negative infinity. I have indeterminate form if I push that through right now, which means I have to do a little bit more algebra. All right, so algebraically, we're going to use the same trick, same idea that we did before, and that's to multiply both the top and the bottom by 1 over the variable to the highest degree. So I'm going to multiply by 1 over x, right? This is x to the first power, this is x to the first power, so that's to the highest degree. All right, so in the numerator here, we have the limit as x goes to negative infinity. Oh, that's sloppy looking. The limit as x goes to negative infinity of, let's see, 3x over x just leaves me with a 3. It's awesome because I know what to do with that. Okay, in the denominator, we have to take note of something again. So I'll write this all out so you can see the steps, but I did kind of show this previously. I can show it again, though. There is a little extra twist to this one. I should forewarn you of that. Okay, so we have 4x squared plus 3x underneath the square root. All right, then we have minus 2x. All right, all of this is over x, right? But since it's a common denominator, as discussed before, I can really write this over x and this over x, and it means the same thing. Okay, so notice that the minus 2x over x is pretty easy to work with. You can just divide the x's out. But we know with this square root, I can't just shove the x in there because the x is not a square root itself. That means that I'm going to have to go through and adjust it. So I'll do that. Okay, so this is where it gets extra tricky. We of course have to adjust this x so we can push it into the square root, but something else we have to consider that I've been writing and we haven't explicitly addressed yet is that in this example, x is going to negative infinity. So the question is, okay, well, how do I handle that? The first thing I'm going to do is simplify this. So I have the limit as x goes to negative infinity over 3 over 4x squared plus 3x minus 2, and then this part's over x. Okay, so like I said before, this is the tricky part. I'll explain it. Okay, when x goes to negative infinity, you have to keep in mind that it's moving left, so your x values will be negative. This means if you have, just x, if you run negative infinity through, it's going to be negative, negative, negative. If you have x to the third power, we know when we raise a negative to a third power, it remains as negative. Same as x to the fifth, same as x to the seventh. Anything to the odd exponent is going to remain negative as your x's are becoming negative or are negative. All right, this differs then if x is to a positive power. So if I have x squared and plug a bunch of negative numbers into it, they still turn out positive. When we're running these limits, we have to go through and make this adjustment. So what I'm going to have to do when I make an adjustment is first turn this x into a root so I can push it under, but then recognize that any x's to the first power, to the third power, to the fifth power are going to be negative if x is approaching negative infinity. So I'm going to have to make that adjustment as well. I'll flip back, I'll type that out, and then I'll continue on with the computational part of this. All right, so I typed all that out. Notice that in our expression, well, I guess what I wrote is that we have to make adjustments for any x that's to the first power, the third power, the fifth power, etc. In this example, the only x that's to the first power is the one that we have right here, so the one that we input that didn't get canceled out. So some people will think this x right here is to the first power, but technically since it's square rooted, it's to the 1/2 power, and we know when we have something under a square root, it can't be negative anyway, so we don't really need to make adjustments for that part. All right, so we know that we're going to need to substitute, and this is from what we did in the previous example, x for the square root of x squared. Okay, however, since x is approaching negative infinity in this example, and my x is to the first power, we need negative x, which is really the same thing as negative root x squared. So I need to take that into account when I make the substitution. All right, so going through that, what we now have is the limit as x goes to negative infinity of 3 over, okay, I have root, here. Just gonna smash that all into one step, but I'll put it in 2 because I think it'll help you see it more. Okay, so we have root of 4x squared plus 3x. I know down here I'm substituting in a negative root x squared, discussed over here in green, minus 2, so I didn't do anything with the 2 there. All right, now I can roll this. So I have the limit as x goes to negative infinity of 3 over, okay, so I have this root over this root, so now I have negative, because there's a minus 1 in a sense out in front, so negative root of 4x squared plus 3x all over x squared minus 2. Ooh, I'm running out of room here. Okay, so we have the limit as x goes to negative infinity of 3 over negative root. I'm going to do all my simplification in one step here. So 4x squared over x squared just leaves me with a 4. It's nice to work with. Plus 3x over x squared leaves us with a positive 3 over x. Again, really nice to work with. We have that minus 2. All right, at this point, I'm pretty pleased with what I have because I know I can run the limit and get something that is determinate. So in the numerator, since it's a constant, it's just going to go to 3 regardless of what x is approaching. In the denominator, I have my minus sign right here that I have to hold. Okay, under here, I know I can run the limit through that square root. So 4 is just a constant. It's going to go to 4. All right, with the 3 over x, we should see we have a small constant divided by a number that's getting really big, so that's going to be 0. Right, and then we have the minus 2 on the other side of that, so all that minus 2. This gives us 3 over, okay, root 4 is 2, so that's a negative 2 minus 2, which is a negative 4. All right, so it took a really long time, but we have finally reached our answer. Did this as a separate video because it's a super lengthy example, but it's also somewhat tricky, so I thought it'd probably be a good idea to run through that with you. Okay, so as always, if you have any questions on the homework, make sure that you hop on the discussion board and ask, or come to open office hours. I haven't tried Teams before this quarter, but I think that it could be cool, so definitely try it out if you have time to. Thank you, and I hope you have a good time doing the homework with us.